Introduction. Students, look at these equations. What type of equations are these?
These are linear equations.
Good. And what type of equation is this?
This is also a linear equation.
You're right. This is also a linear equation. But it has two variables. So it's a linear equation in two variables. Today we will learn about the pair of linear equations in two variables. Objectives. At the end of this lesson, you'll be able to understand the pair of linear equations in two variables, explain the graphical method, write the algebraic methods of solving a pair of linear equations, explain substitution method, explain elimination method, explain cross multiplication method, explain the equations reducible to a pair of linear equations in two variables. Pair of linear equations in two variables. Equations which is written using two variables is known as pair of linear equations in two variables. The general form of a pair of linear equations in two variables x and y is a1x plus b1y plus c1 equals 0. a2x plus b2y plus c2 is equal to 0, where a1, b1, c1, a2, b2, c2 are all real numbers and a1 square plus b1 square is not equal to 0. a2 square plus b2 square is not equal to 0. Examples are 4x minus 5y minus 6 is equal to 0 and 8x plus y plus 4 is equal to 0. X plus y is equal to 12 and 7 is equal to y. Graphical method 1. A pair of linear equations which has no solution is called an inconsistent pair of linear equations. A pair of linear equations in two variables which has a solution is called a consistent pair of linear equations. A pair of linear equations which are equivalent has infinitely many distinct common solutions is called a dependent pair of linear equations in two variables. A dependent pair of linear equations is always consistent. The graph of a pair of linear equations in two variables is represented by two lines. If the lines intersect at a point, then that point gives the unique solution of the two equations. In this case, the pair of equations is consistent. If the lines coincide, then there are infinitely many solutions, each point on the line being a solution. In this case, the pair of equations is dependent, consistent. And the last one is that if the lines are parallel, then the pair of equations has no solution. In this case, the pair of equations is inconsistent. Graphical method 2. If a pair of linear equations is given by a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, then the following situations can arise. 1. a1 upon a2 is not equal to b1 upon b2. In this case, the pair of linear equations is consistent. 2. a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2. In this case, the pair of linear equations is inconsistent. 3. a1 upon a2 equals b1 upon b2 is equal to c1 upon c2. In this case, the pair of linear equations is dependent and consistent. Example. On comparing the ratios a1 upon a2 B1 upon B2 and C1 upon C2, find out if the lines representing the following pairs of linear equations intersect at a point are parallel or coincident. 5x minus 4y plus 8 is equal to 0. 7x plus 6y minus 9 is equal to 0. Firstly, we will find A1 upon A2, B1 upon B2 and C1 upon C2 and then compare them. So, A1 upon A2 is equal to 5x upon 7x, which equals 5 upon 7. B1 upon B2 is equal to minus 4y upon 6y, which equals minus 4 upon 6. C1 upon C2 is equal to 8 upon minus 9, which equals minus 8 upon 9. As we can see that A1 upon A2 is not equal to B1 upon B2, so lines will be intersecting. Algebraic methods of solving a pair of linear equations. When the point representing the solution of the linear equations has non-integral coordinates, then the graphical method is not convenient. So we use algebraic methods. There are three algebraic methods. 1. Substitution method. 2. Elimination method. 3. Cross multiplication. Substitution method. The method of solving by substitution works by solving one of the equations, you choose which one, for one of the variables, you choose which one, and then plugging this back into the other equation, substituting for the chosen variable and solving for the other. Then you back solve for the first variable. Let's solve an example. X plus y is equal to 20. X minus y is equal to 10. Step 1. You have two equations. Pick either the first or the second equation and solve for either x or y. Let's pick x minus y is equal to 10 and we'll solve for x. X minus y is equal to 10. Add y to both sides. X minus y plus y is equal to 10 plus y. X is equal to 10 plus y. Step 2. Now substitute x into the equation on top. X plus y is equal to 20. Using x plus y as 20, erase x and write 10 plus y since x is equal to 10 plus y. We get 10 plus y is equal to 20. 10 plus 2y is equal to 20. Minus 10 from both sides. 10 minus 10 plus 2y is equal to 20 minus 10. 2y is equal to 10. Divide both sides by 2. Y is equal to 5. Now we have y. We can replace its value into either equation to get x. Replacing y into x plus y is equal to 20 gives x plus 5 is equal to 20. Minus 5 from both sides. X plus 5 minus 5 is equal to 20 minus 5. X is equal to 15. The solution to the system is x is equal to 15 and y is equal to 5. Indeed, 15 plus 5 is equal to 20 and 15 minus 5 is equal to 10. Elimination method. You now know the substitution method. Another method is called the elimination method or the addition or subtraction method. In this way of solving systems of equations, one variable is eliminated by adding or subtracting the equations. When adding two equations, you basically add all parts of them. Say you had the equations 4x plus 5y is equal to 14. Minus 4x minus 3y is equal to minus 10. Adding them would give 2y as 4. As you can see, the 4x and minus 4x cancelled out, therefore eliminating the variable x, leaving an equation with only one variable y able to be solved. 2y is equal to 4. Y is equal to 2. Now that you have a value for y, you must find one for x. To do this, just substitute the value for y into either original equation and solve it for x. 4x plus 5 into 2 is equal to 14. 4x plus 10 is equal to 14. 4x is equal to 4. X is equal to 1. Your solution of these two equations is 1, 2. Cross multiplication method. Let the two equations be a1x plus b1y plus c1 is equal to 0. a2x plus b2y plus c2 is equal to 0. Be a system of linear equations in two variables x and y such that a1 upon a2 is not equal to b1 upon b2. That is, a1 b2 minus a2 b1 is not equal to 0. Then the system has a unique solution given by x is equal to b1 c2 minus b2 c1 whole upon a1 b2 minus a2 b1 and y is equal to c1 a2 minus c2 a1 whole upon a1 b2 minus a2 b1. Example of cross multiplication. Find the solution set using the cross multiplication method. X plus y is equal to 6. X minus y is equal to minus 2. Solution. Given equations are x plus y is equal to 6. X plus y minus 6 is equal to 0. X minus y is equal to minus 2. X minus y plus 2 is equal to 0. We can observe that a1 is equal to 1. b1 is equal to 1, c1 is equal to minus 6, a2 is equal to 1, b2 is equal to minus 1, c2 is equal to 2. Solution xy is given by x is equal to b1 c2 minus b2 c1 upon a1 b2 minus a2 b1. Now by substituting the values we get x is equal to 1 into 2 minus 1 minus 6 upon 1 minus 1 minus 1 into 1. By calculating we get x is equal to 2. Y is equal to c1 a2 minus c2 a1 upon a1 b2 minus a2 b1. Now by substituting the values we get y is equal to minus 6 into 1 minus 2 into 1 upon 1 into minus 1 minus 1 into 1. By calculating we get y is equal to 4. Therefore the solution is 2, 4. Equations reducible to a pair of linear equations in two variables. There are some equations which are not linear but can be reduced to linear form by making some suitable substitutions. Let us solve an example. Solve 1 upon 2x plus 1 upon 3y equals 2. Equation 1. 1 upon 3x plus 1 upon 2y equals 13 upon 6. Equation 2. Solution. Let a equals 1 upon x and b equals 1 upon y. Then a upon 2 plus b upon 3 equals 2, or 3a plus 2b is equal to 12. Equation 3. And a upon 3 plus b upon 2 equals 13 upon 6, or 2a plus 3b is equal to 13. Equation 4. After solving these equations we get a as 2 and b as 3. Therefore a is equal to 1 upon x, x is equal to 1 upon 2, and b is equal to 1 upon y, which is similar to y as 1 upon 3. These are the solutions of the given equations. Did you know? A point is on the graph of an equation if and only if its coordinates satisfy the equation. The graph of a linear equation is a non-vertical line with slope m and y-intercept b. Summary. Let us summarize what we have learned. Two linear equations in the same two variables are called a pair of linear equations in two variables. The most general form of a pair of linear equations is a1x plus b1y plus c1 is equal to 0. a2x plus b2y plus c2 is equal to 0, where a1, a2, b1, b2, c1, c2 are real numbers such that a1 square plus b1 square is not equal to 0. a2 square plus b2 square is not equal to 0. A pair of linear equations in two variables can be represented and solved by the 1. Graphical method and 2. Algebraic method. Graphical method. The graph of a pair of linear equations in two variables is represented by two lines. 1. If the lines intersect at a point, then that point gives the unique solution of the two equations. In this case, the pair of equations is consistent. 2. If the lines coincide, then there are infinitely many solutions, each point on the line being a solution. In this case, the pair of equations is dependent, consistent. 3. If the lines are parallel, then the pair of equations has no solution. In this case, the pair of equations is inconsistent. Algebraic methods. We have discussed the following methods for finding the solutions of a pair of linear equations. 1. Substitution method. 2. Elimination method. And 3. Cross multiplication method. If a pair of linear equations is given by a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, then the following situations can arise. 1. In this case, the pair of linear equations is consistent. 2. In this case, the pair of linear equations is inconsistent. 3. In this case, the pair of linear equation is dependent and consistent.